All right, in this video, we're going to do page 38 of the math analysis notes. It's the first page of notes 5, and we're going to talk about graphing trig functions. So this is a topic that I really love. It comes in handy so often in so many different kind of like elements and or when you're covering different things. So I think that mastering this is one of the things you should definitely prioritize. And it's not that bad. That's the best part about it, is that like once you kind of know what you're doing with sine and cosine, you basically know what you're doing with all of them. And you can just take that and use it like everywhere you need to. So let's see if we can do that. So we're going to make the best graphs of sine and cosine that we will ever make. And then it's only going to get worse from there. But that's okay. Start high and low, I guess. You don't really hear that very often. But first, complete the table below using exact values. All right, so which one? I guess I'll do sine first. So I'm going to picture the unit circle. So I have my unit circle in my head. And then what I'm going to do is I'm going to picture, stop. I'm going to picture myself starting here and then going this way, right? So I'm just thinking about the y values. So here we go. So the y value at 0 is 0, and then it grows, and then you hit 1, and now it's going to shrink. Whoa. Shrink. And now you're going to get to 0. Now you're going to keep shrinking. So like at this point, we're like here, and we're still going this way. So we're going to keep shrinking. And we'll hit -1, which puts us here. And now we're going to grow again because we hit the minimum value. So we got to do this. And then finally, we're at 0. All right. Then for cosine, it's like basically the same thing, right? So we're going to start here, but we're still going counterclockwise. And so we start at the biggest it'll ever be, and then it's going to get smaller and hit 0. So now you're here, but you're still going counterclockwise. So you're going to get smaller, and then we'll hit -1, which puts us here. And now we have to get bigger because we're at the minimum. So there's nowhere to go but up. And we get to 0 again. And then from there, we're going to keep increasing. So 1/2, √2/2, √3/2, and 1. Okay. So you'll notice that there's like a couple of the like columns that are sort of grayed out. If you notice, those are actually the quadrantals, and they're going to be very important to this process. So these are a big deal. I mean, I know they're already shaded in gray, but I want to highlight it again just so you definitely notice that. So here's what we're going to do. We're going to use the table, and we're going to create a graph of sine. But first, let's look at this graph paper, which is kind of weird looking. So the easiest thing, I think, to guess is what's happening on the horizontals. So on the horizontals, these are spaced out a little weirdly. It's actually spaced out. So this is 1/2. This is √2/2. This is √3/2. And this is 1. And then in the negative direction, same deal. -1/2, -√2/2, -√3/2, and -1. Okay, so that's what's happening on the y-axis. How about the x-axis? I mean, they're not like evenly spaced, but they're like kind of evenly spaced. If you picture the unit circle, it probably reminds you a little of the unit circle. The unit circle has like a weird gap, right? So you start off, I might end up erasing this, but we start off like this. Oh, maybe I should do start off like this. Nope. One more time. We start off like this. And then we have, whatever, this. I definitely should have, I should have done the lines first, but I didn't. You start off at 0, but then the next one's kind of like here, 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 and then a gap, and then here. Well, this looks very similar to that. And in fact, what's happening is that this is pi/3, and then pi/4. No, it isn't. Oh my gosh. Pi/6. This is pi/6, then pi/4, then pi/3, then pi/2 is here. So I'm actually not going to label everything. And then it'll be 2 pi/3, 3 pi/4, 5 pi/6, and then pi. So again, not labeling everything, just showing you what I'm counting. And then it'll be, we'll go 7 pi over 6, and then 5 pi over 4, and 4 pi over 3, and then 3 pi over 2. So what I'm going to do is I'm just going to label the quadrantals because they're definitely the most important, and also it's just too much. If you start labeling everything, it's way too much. So here, negative pi over 2, negative pi, negative 3 pi over 2, and then negative 2 pi. So I labeled the quadrantals, but all of them are there. Now this type of graph paper doesn't really exist. I made it specifically for these notes so that we could do it. So I used a program called GeoGebra. Later in the year, we're going to use GeoGebra just extensively. But what we can do, because of the way it's set up, is we can plot all of the points that are in our table like very accurately. So I'm going to start doing sine, and I'm just going to be going, 0, 0, and then pi over 6, 1/2, pi over 4. So I'm just going to keep going in order. So I'm going to plot some points. So 0, 0. Then I'm going to go here, here, here. And you can see it taking shape, which is very cool, in my opinion. And because we have every kind of lattice point, we're going to get a very nice graph. Probably the best one you ever do. And you can go backwards and just follow the trend. So you know that the fourth quadrant of the unit circle is between 0 and, well, negative pi over 2 and 0, right? Is one way of saying it. Or 3 pi over 2 and 2 pi. Coterminals, they give you the same quadrant. So let's keep going. Let's actually finish before we try to like talk about stuff. Kind of can't help myself. I just really like talking about this stuff. All right, now we got to fill in our curves. So it's kind of linear-ish, and then it's going to curve at the top, and then this. So people like to make these way too straight when they're doing it. So if it looks too pointy, you can expect to lose some points if it's graded, because your curve's got to be kind of curvy. So we get this. Now I feel like I could kind of cheat and just copy that, but I'm gonna not. I feel like I really wanted to though. This a little shaky going this way. Go here and then up. So if you're not sure what to do, it's not perfect, but aim for something that's kind of like a parabola. So this is our graph of y equals sine of x. And one thing that I want you to notice is that, yeah, there's like a lot of points on this graph, but if you had only graphed these key points, you definitely could have filled in that curve. And that's what we're going to do. And if you had only graphed these, you definitely could have filled in that curve. So we're actually going to focus on basically the quadrantals. Those are our key points. And so there are actually 5 key points. So 1, 2, 3, 4, 5 key points gives you one cycle of the graph. And if you look, we go an intercept, maximum, intercept, minimum, intercept. That's one cycle. And then intercept, maximum, intercept, minimum, intercept. 2 cycles. So this is what sine looks like. And the way that I remember the pattern is I remember it as intercept, maximum, intercept, minimum, intercept. So capital M means a maximum, lowercase m means a minimum. The i's are actually for the intersection points of what's called the sinusoidal axis, which we'll talk about a great deal. But for this curve, the sinusoidal axis is the x-axis. So the sinusoidal axis, because it's a sine curve, it's a sinusoid. The sinusoidal axis, it's actually the average of the maximum and the minimum. It's kind of like the halfway point. The graph kind of looks like it's hanging kind of symmetrically sort of about that axis. So a lot going on. So we have these key points. We got our graph. I'm going to do the same thing for cosine now. So I'm just going to make sure that I start at 0, 1. And if you start at 0, 1, you almost can't screw up. Like you could, but you almost can't. So this will be a graph of cosine. Well, I'm saying x, but the notes are saying theta. Doesn't make a difference. I don't know how important it is to really label everything on this because, you know, there's too much. Pi over 2, pi. Definitely the quadrantals, though. Those you got to do. Negative. I find it very confusing when it's zoomed out. Almost made a pi wrong. Negative 3 pi over 2 and negative 2 pi. So there we go. All right, here we go. We're going to start at 0, 1. And if we do that, almost impossible to mess up. Almost. You know, where there's a will, there's a way. You could always screw up anything, but shouldn't screw it up. And just follow the pattern here. So there's a lot of stuff to notice about the graphs of sine and cosine. One thing that you'll notice almost immediately, I seem to have crashed. Hold on, let's come back. Let's get back in there. Let's see what I lost. Oh, I lost everything. Good grief, that is annoying. All right. I wonder if that's because I have like too many things in my in this app. Maybe I should start offloading some of them. All right, so disappointment overtakes us. Here we go. Just more practice, yay. Because I definitely need more practice. All right, so what? All right, we're going for it. So I think I was telling you that there's no way to mess up, and then I crashed the app, which, you know, classic. What? What did I do wrong here? Oh, I skipped one. Holy cow. No way to screw up except all the ways I'm screwing up. Good deal. Okay, so I think I'm doing it right now. It's like over 1, up 1, over 1, up 1. It's almost like you're using slope, but the slope actually varies at every point, so it's not really that. But it is just using the grid lines, so stay on the lattice points. You should be fine. This is the only time you'll ever have a graph paper like this, though, because, you know, you don't really need it. And also, you almost never just graph cosine. Like, you graph things to do with cosine. So let's fill this in. Let's see if we can. Okay, so you might notice. So you want to, at the end, put the arrows, but like don't indicate that it goes up because it definitely doesn't. Like we actually know that at that point, it's got to start repeating the pattern again. So like it's not going up, it's going to curve back down because that's a maximum like this. So this is y equals, I'm going to call it cosine of theta this time to be consistent with the actual notes. So there we go. So one thing that you'll notice, the graph of cosine and the graph of sine, they look really similar. They actually sort of have the same patterns, right? There's like maximums, intercepts, and minimums. They're just in different places. So when I look at cosine starting at 0, I think that the pattern is maximum, intercept, minimum, intercept, maximum. I can see that the range is -1 to 1. It looks like they're just offset by like pi over 2. Like if I took cosine and shifted it pi over 2 to the right, I would get sine. If I took sine and I shifted it pi over 2 to the left, I would get cosine. That's actually a big deal. And if you think of your cofunction identities, like maybe there is something there. But anyway, these are the basic graphs. And what we're going to do is we're going to create less basic graphs. So here are your key points. 1, 2, 3, 4, 5. If you're doing the other period, so it's called a period, one full cycle of the graph is called a period. 1, 2, 3, 4, 5. 5 key points in each cycle, in each period of the graph. So I'm going to stop the video here. I'm going to come back in the next video. We're going to do some more stuff. So I will see you there.